Thank you, everyone, for joining us at Griffith Observatory for a live broadcast of the southernmost moon. This kind of thing only happens over a 2-year period every 18.61 years or so. I'm Dr. Ed Krupp, director of Griffith Observatory, and this cheering and unusual astronomical event is part of a 2024-2025 campaign to follow the greatest monthly excursions of the moon. Last night, Friday, July 19th, we showcased the southernmost moonrise. We return now, well before dawn, on Saturday, July 20th, for the southernmost Moonset, which is brought to you by Griffith Observatory, Griffith Observatory Foundation, and the City of Los Angeles Department of Recreation and Parks. Griffith Observatory cameras are now targeting this view of the southwest horizon from over the observatory's lower west terrace. In a short time, the moon will set on this line just about as far to the south as we ever see it. The waxing gibbous moon, now just a day from full moon, will set along the illuminated line and into the Pacific at about 4:46 a.m. Pacific Daylight Time. It's still dark in Los Angeles, and that makes it harder to see the horizon. But the Griffith Observatory live stream broadcast team is on the moon's case. The broadcast team includes Patrick So, Observatory Theaters Manager, Matthew Burlando, Production Engineer, Vanessa Alarcon, Observatory Astronomical Observer, Digital Communications Coordinator Pixie Iwata, Production Assistant Ella Ritz, Camera Operator Jennifer Wong, and Stage Manager Michael Noble. We first broadcast the southernmost moonrise last month on the evening of June 21st, as we did again yesterday, and in the early morning on June 22nd, we moved to the west side of Griffith Observatory, as we have now, to the Major Standstill Southern Moonset line inscribed on the lower west terrace. The moon hasn't risen and set this far south in 18 years, and really more than 18 years. The moon's orbit is now tilted at the greatest angle outside the path of the sun. Those white disks represent the moon, and the circle is its orbit. The other circle is the sun's path, and the moon's orbit is outside of that other circle. On the ground, this means for about the next year and a half, we'll see the most northern and southern moonrises and moonsets the moon ever reaches, and this time is called the Major Lunar Standstill. Here again is our Major Standstill Moonwatch view. The southernmost moon is headed toward the illuminated line. The greatest excursions of moonset are marked on Griffith Observatory's lower west terrace, along with the solstice and equinox sunsets and moonsets when the monthly excursion is least at the minor standstill. Here, the gray lines for the northern moon's inner and outer limits flank the gold line that points northwest for the summer solstice sunset. The most northern and southern moonsets last happened in 2006, when the observatory was still under construction for renovation and expansion. The stone for the line had not yet been placed into the pavement. This, in fact, is the Major Standstill Northern Moonset on January 28, 2006, on the lower west terrace at Griffith Observatory. Between now and around December 2025, the moon will, each month, rise and set as far north and as far south as it ever can, as shown in this view of the moon sets and the extreme positions of the sun at the solstices. Although we call this period the Major Lunar Standstill, the moon doesn't really stand still. Its monthly excursions just reach roughly the same maximum limits each month for about 2 years. Now, the sun does something similar, but does it over the course of a year, not like the moon, really over 18.6 years. In this illustration of the sunrise limits on the eastern horizon, the June sun is rising on the left as far north as we ever see it. And 6 months later, in December, it rises at its southernmost limit on the right. To the unaided eye, the position of sunrise and sunset at these times of year does not seem to change for about 3 days, and the sunrise and sunset then seem to stand still, and the time when this happens is called the solstice, which means sun still. Well, the Griffith Observatory cameras are still targeting the southwest horizon, where their southernmost moon will soon disappear. If we think of the sky as a hemispherical screen, like a planetarium dome, we can imagine how the sun, moon, planets, and stars all rise somewhere from the eastern half of the horizon on the near side of this view, and then climb up the sky to their greatest height, and then head back down to the western half of the horizon on the far side of the dome. The celestial objects all rise and set like this because the Earth is spinning on its axis, and that makes the sky seem to turn around the North Celestial Pole, a spot directly above the Earth's North Pole. If that were all that moves, the sky would be simple, but other objects like the sun, moon, and planets also all move around the sky on their own paths at different rates. The sun's path through the sky is called the ecliptic, and it is just a reflection of the Earth's orbital motion around the sun. Sun takes about 365 days, a year really, to complete its circuit, and the tilt of the sun's path shifts the sunrise and sunset from north to south and back to north again in a year. Each month, the moon circles the Earth in 27 days, and the tilt of the moon's orbit guarantees that the moonrise will migrate from north to south and back to north again in that time. So the moon does in about a month what the sun does in a year. It moves from north to south and back again, but the moon does something else. The moon's monthly limits gradually change. And over 18.61 years, the moon's limits move from outside the sun's limits to inside the sun's limits, and then back outside the sun's limits again. The moonset lines on the lower west terrace of Griffith Observatory make this obvious. The northern inner and outer limits flank the summer solstice sunset line that points to the northwest here. The southern inner and outer limits flank the winter solstice sunset line that points to the southwest. And when the moon rises and moon sets reach these limits, the limits don't seem to change much from month to month. And these periods are the standstills, one at the moon's inner limits and another at the moon's outer limits. The moon's limits still change through these periods, but the change from month to month is small, just as the daily change of the sun's position at the solstices is small. And that's why we call the moon's limits the lunar standstills. We are now in the season of major standstill, the time when the moon's monthly limits are far outside the sun's annual limits. The extreme moonrises and moonsets are farther north and farther south than the solstice sunrises and sunsets. In another 9.3 years, the limits for the moonrises and moonsets will be inside the solstice points and will be at the minor standstill. The monthly limits then will gradually increase again, and in 2042, we'll have the next major standstill. So mark it on your calendar. Well, the moon behaves this way for two reasons. First, the moon's orbit is tilted a bit compared to the Earth's orbit around the sun, just 5 degrees. And second, thanks to the gravitational pull of the sun, the moon's orbit swivels. That changes the angle of lunar excursion and the amount of the moon's reach. This Fisk planetarium animation shows how the rotation of the moon's orbit changes the angle at which we see it. And these edge-on views of the Earth, Sun, and Moon show how the Moon's orbit flips back and forth at a greater angle to a smaller angle and back again with respect to the Sun. Although the varying limits of moonrise and moonset are noticeable over time, most people, including professional astronomers, have no experience with this aspect of the moon. You have to track the moon systematically, month after month, for several years to realize that the moon is doing this, and you would have to track it for several 18.61-year cycles to see and understand the full pattern. And that's what we're doing at Griffith Observatory this morning. Okay, we're still several steps ahead of the major standstill, the southern moonset, but the moon is headed to the horizon and to the line. Now, despite the difficulty in mastering the lunar standstills, some investigations of archaeological monuments, particularly Stonehenge, seen here, have led some investigators to propose that lunar standstill alignments were designed into some ancient and prehistoric sites. In the 1960s, C.A. Newham and an astronomer, Gerald S. Hawkins, each independently identified lunar standstill alignments in the station stone's rectangle at Stonehenge. This rectangle enclosed the main circle of stones and was constructed earlier, perhaps 4,500 years ago. The long sides of the rectangle coincide with the directions of Major Standstill southern moonrise and Major Standstill northern moonset. Here is the view to Major Standstill southern moonrise at Stonehenge, and here is the Stonehenge station's view to Major Standstill northern moonset. Hawkins also proposed sight lines between certain gaps in pairs of archways formed by the large sarsen stones, erected maybe 500 years later. And this pair of openings, for example, accommodates the Major Standstill northern moonset. Now, Stonehenge was not the first prehistoric monument assigned a major lunar standstill alignment. In 1908, British naval officer Boyle Somerville published a major standstill northern moonrise line for the Callanish stones in Scotland's Outer Hebrides. And in the 1980s, the Pontings instead favored an alignment to the low southern moon, aligned with the long avenue, as you can see in the plan. And here that transiting moon hugs the horizon in June 1987. The late Aubrey Burrell was the leading expert on prehistoric stone rings, and he identified major standstill southern alignments in the recumbent stone rings in northeast Scotland. This is the view to the southwest from the center of the Castle Fraser stone circle. The big horizontal stone operates like a stage across which the southern moon dances. Jack Eddy, a solar astronomer, spotlighted a 2,000-year-old major standstill northern moonrise alignment with the axis of the prehistoric Hopewell Circle and Octagon Mounds at Newark, Ohio. The axis is right here between those two features of the site. Stephen Patricia reconstructs here Newark's major standstill northern moonrise. An ancestral Pueblo great house, about 1,000 years old, at Chimney Rock National Monument near Pagosa Springs, Colorado, accompanies the restricted view of the major standstill northern moonrise, framed by the distinctive rock pillars. Some believe the great house was built on this demanding mountain ridge to accommodate the northernmost moon in the Chimney Rock Gap. Griffith Observatory astronomical observer Vanessa Alarcon photographed the northernmost moon last October when the broadcast team was there, and Dr. Amanda Bosch of Lowell Observatory caught last December's full moon at Chimney Rock. Deliberate inclusion of lunar alignments in ancient and prehistoric monuments has not been proved and remains questionable. Griffith Observatory, on the other hand, possesses intentional lunar alignments, and throughout the rest of 2024, most of 2025, Griffith Observatory will broadcast selected moonrises and moonsets at the moon's maximum excursion. We are now broadcasting live over the observatory's lower west terrace along the major standstill southern moonset line, which heads southwest and continues through Hollywood, Century City, and Santa Monica, and on to San Nicolas Island and the Pacific Ocean. The moon may be standing still, but Griffith Observatory never stops moving. As the moon heads closer to the southwest horizon, it's beginning to take a rather unusual form. We're getting a lot of distortion on the visible disk of the moon. It's almost as if something's nibbling it from one side or the other. And this is really an effect of the atmosphere as the moon gets lower and lower. We've got an inversion layer over Los Angeles tonight and a fair amount of haze and smog in the air as well, all cutting in and affecting that really gorgeous orange view of the moon. But it makes it a spectacle worth picking up at this early hour for folks up here at Griffith Observatory on the broadcast team.
Thank you for joining us for our live coverage of the Major Standstill Southern Moonset event. As you can see, the moon is already part of it, partway below the horizon, and the upper part is still above the horizon. We're looking at the last few seconds as the moon is about to set here in Southern California. The moon reached the southernmost point on the horizon and will be setting at 4:46 Pacific Daylight Time. And we are just about right at that moment where the moon will completely disappear from our view and from our view here in Southern California. And just the last top limb of the moon, very distorted by the atmospheric effects, and the thick layer of the atmosphere is the last limb of the moon shines through the very thick layers of the atmosphere just over the Pacific Ocean. And we're almost there. Just a few seconds. Just almost there, and it's gone. The moon has officially set here in Southern California. We'd like to thank Griffith Observatory, Department of Recreation and Parks, and the City of Los Angeles, and of course Griffith Observatory Foundation for making this broadcast possible. Thank you very much for joining us again for this beautiful moonset here at Griffith Observatory, and thank you for tuning in to our broadcast. We hope you have a pleasant morning.